So on this one, a study at a certain restaurant found a linear relationship between outdoor temperature and average number of cups of hot chocolate sold. Now just think about that sentence right there. Hopefully that kind of makes sense that that would happen, right? Like if it's colder outside, you'd probably sell more hot chocolate. If it's warmer outside, probably not as much, right? The relationship can be approximated by the following linear model, which is just the function, by the way. So linear models, of course, we know those can be shown as graphs, but they can also be shown just as pretty much straight equations or functions like this. So X is the outdoor temperature, so that's nice. They're telling us this much. In Fahrenheit, by the way. And C of X is number of cups sold. So C for cups, X for Fahrenheit. All right, so what does the slope represent? Oh, we don't even have to solve anything right here. All we got to do is say what the slope represents and then what the y-intercept represents. So it'd be nice for us to identify first what the slope is, and the slope here is just the coefficient of X, negative 0.955. I'm going to write a sentence for this, although I think on the homework it's just kind of a multiple choice kind of thing for you to figure out what that represents. Okay, so what does the slope represent in this case? Now, over here, slope should be rise over run, right? So you could even say it's negative 0.955 over 1. It's just, what does it represent? Well, it said, so the number of cups sold, that's our y value. It's just shown in function notation. So that'd be negative 0.955 cups. And then the 1, since I made it a fraction, the 1, remember it's always y's over x's. So the 1 right there would have to, we know that the y's are cups, and then the 1 here would have to be, I'm going to put degrees. I'm not going to spell Fahrenheit, not because it's so long, but because I really don't know how to spell it. So degrees, maybe degrees, F for Fahrenheit, there we go. So let's go ahead and write this out then. So the slope, what does it represent? Let's go ahead and put something in here. The negative, by the way, for our negative 0.955 means that the cups sold will drop. Again, that's addressing the negative part of it. 0.955. I'll put 0.955 for every 1 degree. Here we go. Fahrenheit. It should spell check. Oh, there it goes. Boom, I did it. 1 degree Fahrenheit, and that 1 is positive, by the way, so I'd say 1 degree Fahrenheit increase, if I could just spell that right too, okay? So that right there is what the slope represents. Is there different ways to represent that? Yeah, but I'm just using strictly the numbers that was given. And again, you can always put something over 1. And slope should be a comparison of 2 different values because it's a rate. And a rate compares 2 different values, in this case, cups and degrees Fahrenheit. The next thing here is the y-intercept, which is just the plus 99, which on a graph would be 0, 99. It's 99, 99 what? Well, we know that C in the end ends up being cups, so it'd be 99 cups. See, it's a y value here, so it should just represent whatever the y values represent, and they told us up here it's number of cups sold. Now, more specifically though, because it's 99 cups, but remember the ordered pair has the 0 here. It's 99 cups of, I should have typed this out, of hot chocolate. You're gonna have to make this smaller to make it fit. But more specifically, when the temperature is 0 degrees Fahrenheit. Sorry, that got kind of small there at the end. So with the y-intercept, I want to also address both things, right? Cups and degrees, because it's built into the ordered pair, and then slope as well, because it's a comparison of the 2 as a ratio. So this also means that if you kind of reverse the negatives, right? that means that if it went down 1 degree in Fahrenheit, you'd expect to sell almost a whole extra cup of hot chocolate at that point. Now, you should be able to think, well, is it always going to be linear like that? Probably not. Maybe Fridays there's more or something like that. But this is just using the information that they gave us. I don't know, maybe you guys don't even want to think about it in nonlinear terms as well, but I think we'll see that in a future module.